Hello, everyone. Thank you for joining my session today. Today, I'm going to be diving into some practical techniques to make your Angular applications run blazing fast. And I think these are some techniques that you can apply right away. Performance is not really an option. It's not really optional. A delay of even 1 second can cause a drop in conversions, and like when we're talking about poor performance, it hurts SEO, user retention, and also accessibility. So Angular gives us the tools that we need to essentially wield them smartly. So with the time we have, we'll focus on three areas: lazy loading, smart, change detection, and signal-based state. Before we get started, let me introduce myself. My name is Sonu. I'm a senior Angular developer consultant. I have worked in the past with various top Forbes 100 companies and helped them with their Angular projects. I am an Angular GDE and also a Microsoft MVP. I also co host two podcasts, one for generic tech topics and another one focused on advanced Angular topics. Besides that, I just recently started an online Angular meetup as well. Cool. So let's start with routing. So, one of the great features Angular provides out of the box that boosts performance is lazy loading. It's very powerful and a simple technique that allows us to delay the initialization of certain parts of our application until they are actually needed. So instead of loading everything at once, lazy loading lets you load features, modules, or now standalone components in smaller chunks. So this approach offers various benefits. So it can reduce the bundle size and speed up the initial load time. And with each lazy loaded module or component, Angular automatically generates a separate JavaScript file chunk. And that means the user only has to download the essential resources initially. And if you wanted more control, we can use the preloading strategies to dictate which modules should be preloaded. So to illustrate this concept, let's consider the following example. So imagine we have a route configuration that includes 10 components, all set to be eagerly loaded. So this means that every time someone accesses the application, all 10 components are loaded right away, regardless of whether they will be used immediately or not. So in this scenario, every component gets bundled into the main chunk. If we decide to implement lazy loading, the only change required is to adjust our routing configuration to use load component. For those utilizing or still utilizing modules, we can switch to load children. Now, if we replicate the same number of components from earlier example, lazy load them, and build the application again, you will see a substantial difference. You'll notice here that the size of the main bundle has decreased by 50%. Now, while lazy loading is well-known and effective strategy, there's another technique we can employ to further boost performance. It's called preloading. And preloading is a feature that allows us to load components in the background without the user needing to manually activate the route. So this means that even while the user is engaged with one part of the application, we can quietly fetch resources they might need next. And by combining lazy loading with preloading, we can achieve the best performance and user experience. So that means our initial bundle will be small, as it will only contain the most important code, and the remaining bundles will be loaded in the background. So in a module-based application, implementing this is as simple as using the preloading strategy property and setting it to preload all modules. So this configuration allows Angular to automatically preload all lazy loaded modules when the application is up and running. And for standalone components or applications, we need is the preloading, add the preloading function to the provide router within the application configuration. Okay, so again, here are the key points about routing, right? I won't dive more into the details since it's already a well-known feature, but you can't overlook it when you're discussing performance. Now let's shift gears to change detection. Change detection is very resource intensive if not handled correctly. And one of the most effective techniques is to optimizing uh, change detection strategies and utilizing signals. And in this section, I'll explore how to do that. So before we dig into the strategies, let's try to understand how the change detection process works in general. So long story short, the process involves two stages. The first stage marks the clicked component as dirty, which tells Angular, hey, this component needs a checkup. The second phase is when the Zone.js library comes into play. So Zone.js is a library that monitors various asynchronous browser activities such as XHR requests, DOM events, any timer, send interval, set timer, and so on. You could also think of it as a thread local storage for JavaScript VMs. So while Zone.js can monitor actually all the states of sync and async operations, Angular provides an additional service called ngZone. So this service creates a zone named Angular to automatically trigger change detection. For example, when a sync or async function is executed. So when an asynchronous event happens, ngZone prompts it to initiate the change detection process. And in that stage, Angular captures an event through the micro task observable and traverses the view tree to detect and propagate any changes. And when it's time to determine what should be checked during that process, Angular relies on different criteria for checking that component, inspecting various flags associated with the view and its mode to determine if any updates are necessary. And if updates are needed, then a component template gets updated by calling the refresh view method. So now you have a little bit of an understanding how change detection works. Let's look into the strategies, right? So in Angular, there are currently two strategies. And when I last talked to Minko about that in our Angular podcast, he mentioned that there might be a third one, which will be tied directly to signals, but we'll have to wait and see on that. So by default, Angular's change detection strategy triggers unnecessary checks and updates throughout the entire application, and it relies on the check always flag. Okay, so which again tells Angular, hey, check everything regardless of whether any changes have occurred. And you might say, sure, this works, but it's an overkill, especially for performance sensitive applications. And to make things faster, Angular introduced the on push strategy, which only checks components when their input reference changes. Okay. And when that happens, we mark components to check using the mark for check method, or when an event occurs like an asynchronous HTTP response. So this means that instead of refreshing the entire component tree, we only re-render the components directly affected by that change with all its ancestors up to the root. So we're just focusing on checking a specific branch of the nodes in the component tree rather than the entire tree. So this is great and works nicely. And now you're able to essentially um, increase your performance because Angular checks only a specific tree. But there's a better way to increase performance, and that is by using signals. So let's take a look what signals can do for us to make this even more performant, especially um, if you're using RxJS to manage your state, for example, using behavior subjects. So let's start by asking the big questions. Why do we need signals? Like change detection work fine. We have async pipes, right? We have RxJS, right? Why not just stick with behavior subject, observable, and async pipe, right? So RxJS and observables generally are very powerful. There's no doubt on that. But I think they can be overkill for simpler use cases. And you often end up writing boilerplate code just to track state, subscribe, unsubscribe, next, pipe, and whatnot. And here's the catch: RxJS is not directly tied to Angular's rendering system. So that means when a value changes, Angular pretty much has to guess whether to re-render, often triggering more change detection than needed. And if you have a large application, this can lead to performance bottlenecks. So Signals fix this by being part of Angular's core reactivity model, which RxJS is not. So when a signal changes, Angular knows exactly what part of the DOM to update. So no more check in everything just in case. It's precise and it's fine grained. Also, there is no need to manually unsubscribe. You don't need an async pipe, and you rarely need to call um, change detector ref or the detect changes function, because Angular knows when and where changes happens. So in summary, signals let you write simpler, cleaner, and more performant code, especially for local and UI bound state. Now for global streams like WebSocket connections or event buses, RxJS is still the way to go. But for component-driven UI state, signals are often the better tool. So now we know why signals matter. Let's look at how to actually use them. So this is one of the simplest examples, creating a signal inside a component. So here I'm defining a signal called count and initializing it to 0. To update the value, we call update and pass the function that receives the current value. So it's like next in the behavior subject, but way more ergonomic. So where would you use this? Right? So you can think of counters, toggles, simple form states, any local UI state where you don't want to over-engineer it with RxJS, right? And also notice here, there is no subscribe, there's no cleanup. Angular knows when count changes and will automatically re-render anything that depends on it. So this declarative style makes code easier to reason about. And the reason, and the rendering is scoped to the parts that actually read the signal. So now let's connect the signal to the template. So here you'll notice we're using the count as a function and not as a property. Signals are functions, okay? So you call them to get the current value. And this ensures that Angular knows you're reading the signal. So why is this important? Because Angular's reactivity system tracks that read. So if count ever changes, Angular knows exactly which part of the DOM to update. It does not need to run change detection across the whole component tree. That read of the function is where Angular stores the DOM, and it knows how to update it and where exactly to update it. So you can think of it like an automatic dependency tracking. Angular's reactivity is built into the template, right? And again, if you compare this to using async pipe, where you still have to manage the observable stream and maybe even rely on and actually rely on zone-based change detection, right? Here, it's direct, it's minimal, and it's a lot faster. So let's go one level deeper with a real UI scenario, filtering a product list. So here we have two signals: filter for the user search, for the user search input actually, and products for the raw product data. So the interesting bit is filtered, which is a computed signal. This is how you build derived state. So when filter of products change, filtered recalculates automatically. Now think about how many times you have to wire up a pipe with a map operator on a behavior subject just to transform state. Now you don't need to do that. This is more like views computer props or solid.js, just with Angular's type safety and DI support. And you can bind filtered directly to the template. So when the user types in a search field, only the relevant rows will re-render. So a common question is, can we use signals in the services or in services like we do with the behavior subject? And yes, the answer is yes, absolutely, you can do that. So here is a user service holding the current logged in user. So user here is private. It's the actual signal holding the state. And we expose a read-only computed signal user. So components can read it reactively, reactively, but not mutate it directly. So this replaces a behavior subject and get user as observable with something much cleaner and direct. And when you call set user, any component that reads from the user function will automatically update. Again, no need to emit, no pipe, no subscriptions. And this kind of patterns works beautifully in real world applications. You can imagine this being used in a nav bar or show the logged in user's name or conditionally showing a logout button. So let's wrap it up with why this actually matters, especially for performance. So with traditional RxJS in Angular, every little UI event could trigger a broad change detection cycle. Even if just one item changed, Angular didn't always know where, so it played it safe and ran checks on the entire component tree. So Signals solve this by providing fine-grained change detection. And if a signal changes, Angular knows exactly what DOM bindings to update. Nothing else re-renders. And again, no subscribe, no unsubscribe, meaning less memory churn or cleaner logic, right? You're not juggling async emissions or worrying about leaks. So this becomes crucial in larger applications. If you've ever debugged performance issues, tied to zone triggered re-renders or async emissions, you will appreciate the precision that Signal offers. So what is the big takeaway here? It is signals are simpler to write, easier to understand, and much, much faster, especially for UI bound state. So let's recap what we have covered today. So we started with routing strategies using lazy loading to cut down initial bundle size and explored pre-loading to balance speed with user experience. Then we looked at change detection, especially the power of on push to avoid unnecessary DOM work. And finally, we took a deep dive into Angular signals, which lets us write reactive performant code without relying on RxJS, especially useful in services and components where subscriptions can get messy. And if you're building large apps or even smaller ones where startup time matters, these techniques can make a real difference. So that's all we have prepared. I hope you found these tips helpful. I can't wait to see you apply them in your projects. As always, please connect with me on LinkedIn. And yeah, feel free to reach out if you have any questions. Thank you so much.